Hello students, welcome to IMS Gate Academy. But in the foundation course, I started already electronic devices and circuits. Now this is semiconductor part 6. But I explained what are the basics of insulators, conductors and semiconductors I explained. And also types of semiconductors I selected. And I explained N-type extrinsic semiconductor in the last class. And also I will discuss a part of analysis on N-type extrinsic semiconductor and energy band diagram also. Understand now. And today we can discuss about P-type extrinsic semiconductor also. Understand now. But here, before going to the lecture, just I want to give the information regarding the IMS Gate Academy here now. If any students are willing to take the admission in IMS Gate Academy, they can make a call to these numbers. They can make a call to this number. But when the students gets admission in IMS Gate Academy, what those advantages are there now? You should know well about the program futures, then you can understand what benefits you will get it. More than 800 hours of the live classes with live interactions possible. More than 800 of the live classes with live interactions. And also IMS Gate Academy provides theory book, exercise book. Exercise book contains more than 4,000 questions. More than 4,000 questions. It contains level 1, level 2, level 3 questions. Level 1 basic questions only. Level 2 gate level questions you can find. Still the students wants to go in depth of the subject, they need to do the what? Level 3 questions also. I think these are the questions are just enough to crack the gate. Understand now. Not only these more than 4,000 questions, but IMS Gate Academy provides more than 34 years of the gate questions banks with video solutions. But in these books, all the gate questions were solved, and also alternative solutions also given for the what now. Solutions are given and alternative solutions also given for certain questions, and also given video solutions for certain questions fully now. So every gate question they can practice in a better way. And also 12 personalized one-to-one mentorship sessions possible here now. What is personalized one-to-one mentorship? The students can discuss directly with the mentor, and he can get the relevant information from the mentor. What is that relevant information? If the students wants to have the preparation guidance, they can get from the mentor. But a mentor is going to give the guide, he will guide the student, but how to prepare for the gate, and what are the subjects they need to start initially, and also for each and every month you can discuss with the the faculties or mentors, and you can get the relevant information. Understand that now. And also more than 130 online tests with video solutions to the mock test and many more. But don't waste your time, and if you have an interest to join in IMS Gate Academy, immediately you make a call to these numbers and join in IMS Gate Academy. You are going to get more benefit in this organization, in this institution. And also one more point you have to remember, but the mentors are all the mentors are experienced. Each and every mentor having the more than 10 years experience. So good subjects you can get, and that subject is just enough to crack the gate, I hope it. Understand now. Okay, we can enter into the subject now. We can enter into the subject now. But the point, one more point I would like to inform to the students. But when you are enjoying with the subjects, you subscribe and share it to your friends also now. Understand now, share to your friends also. And also please try to please try to like the video if you felt happy only now. Understand now. So first of all, where from what we have to start today. But the N-type extrinsic semiconductor, in the last class I explained N-type extrinsic semiconductor. The last class I explained some more information I want to give here now. But in the n-type extrinsic semiconductors, I said the pentavalent atom is doped to get the n-type extrinsic semiconductor. Because of the addition of the what now pentavalent atom, new energy level is going to form in the energy band diagram that I want to draw here now. The diagram will be plotted like this. Energy band diagram is plotted like this. You know very well, this is the conduction band. This is the valence band, you know very well. You know very well. And also one more energy band will be created here. One more energy level will be forming like this. One more energy level will be forming here now. But we know very well, this is nothing but the EV, valence band energy, you know. This energy level is nothing but the EC. The conduction band, you know very well. This is the valence band is possible. In the n-type extrinsic semiconductors, majority carriers are electrons, you know very well. The excess electrons will be occupying what now below the conduction band energy level. That means a new energy level is formed. This energy is nothing but the ED. One discrete energy will be forming here now. The excess electrons are going to occupy these places. These are all the electrons are existing in this below the EC level you can find. Now try to catch my point. Initially electrons are existing in the valence band. Initially all the electrons are existing in the valence band here. But sudden excess electrons are occupying this level. So valence band is here, but the conduction band is here empty. But these are the electrons. These are the electrons. To move to the conduction band, it doesn't require more temperature. Very less temperature is required. Because of that, these electrons will try to move from this discrete level to the discrete level energy to this conduction band they will reach. This electron will go and occupy. These are all the electrons will try to go and occupy these places. Like that, they are all occupying here now. But I don't say when these electrons are moving to the conduction band, thereby creating the holes. That is not accepted. Excess electrons only here now. They will go there now. But in the energy band diagram, you can't find any holes here now. We can't find. The holes are always existing in the valence band only now. So anyhow, because of the low temperature, electrons move to the conduction band. And still you are increasing the temperature, you think it's so. The electrons which are existing in the valence band will try to move to the conduction band. From here to here they will move. And from here to electrons are moving to this side. Like that, certain number of electrons are moved. For example, I say 3 number of electrons are moved from valence band to conduction band, you think it's so. How many number of the holes are created? 3 holes are going to create only, we can say. Now you please check, in the conduction band we got more number of electrons. These are the electrons are reaching to the conduction band and certain number of electrons from the valence band also. But in the valence band, it creates only, these are the holes only possible now. So what are the majority carriers we are having means electrons only now. That means in the electrons in the conduction band is going to be increased more and more only now. In the conduction band is increasing more. Once the number of electrons are increased, what happens? If the supply voltage is connected, easily current is going to flow through the n-type extrinsic semiconductor. That's why these electrons are going to move very fast. But here, please watch here. You please watch between these ED and EC. Some energy is required. Some energy is required to move the electrons only now. What energy is required to move from ED to EC? That energy is given as a 0.01 electron volts. 0.01 electron volts for 0.01 electron volts. This much energy required for germanium. For germanium, the energy must be 0.01 electron volts. If it is a silicon, you think it's so 0.03 electron volts possible. 0.03 electron volts for silicon, I can say. No. For silicon, that much energy is required only, we can say. Once the electrons are reached to the conduction band, then conductivity will be increasing only, we can say. That point is very important. And I would like to find what concentration of electrons in the n-type material, how we can determine. That point also very important now. How we can determine, I will explain now. But to find Nn, I can say, to find n suffix n, I have taken now. To find n suffix n means it is a n-type extrinsic semiconductor. N is nothing but the concentration of electrons. Concentration of electrons in the n-type extrinsic semiconductor, I would like to find by using the formula. What formula? Let Nd equal to, suppose I have taken Nd is the symbol. Nd is called as a donor impurity concentration. Donor impurity concentration, I can write now. Nd equal to donor impurity concentration. And Nn is nothing but n suffix n. This is nothing but the concentration of free electrons. Concentration of free electrons. Free electrons in the n-type extrinsic semiconductor. N-type extrinsic semiconductor. Extrinsic semiconductor. Nn is nothing but the concentration of electrons. And Pn is nothing but the, Pn means what you can say, concentration of the holes in the n-type extrinsic semiconductor. Is a concentration of electrons in the n-type extrinsic semiconductor. I can say concentration of holes in n-type extrinsic semiconductor. N-type extrinsic semiconductor. Extrinsic semiconductor. Pn is nothing but the constant. That means Nn is nothing but the majority carriers. P means minority carriers only now. But using the electrical neutrality principle, Nn equal to, I can write concentration of electrons in the n-type material is nothing but the holes existence of the poles, Pn plus donor impurity is possible. This is from the the electrical neutrality principle onwards we formed. Nn equal to Pn plus Nd is possible here now. Understand now. But the P is nothing but the minority carriers, Nd is nothing but the donor impurity concentration. That is Nn value. But if I want to find out the Nn value, the Pn you have to convert in terms of Nn only now. That is achieved only by means of the mass action law. In the last class I explained. From mass action law. From mass action law. From mass action law. The minority carriers calculated by Ni square by Nn, you know very well. Ni square by Nn you can write. Then you can substitute there now. Pn value you can substitute here now. Nn equal to, I can write Nn equal to what I can write? Nn equal to Pn. Pn means Ni square by Nn. Ni square by Nn plus what is still left? Nd, donor concentration. Nd. Finally, we formed like this. And just you form one quadratic equation. By using that quadratic equation, we can determine Nn. How we can form the equation here now? Cross multiply Nn square, that equal to Ni square plus Nn into Nd is possible after LCM. So finally, I can write Nn square, that equal Nn square minus Nn into Nd minus Nn into Nd minus Ni square, that equal to 0. The finally one quadratic equation is formed. By using this quadratic equation we can find Nn. Nn equal to minus b, Nn minus plus Nd is possible here now. Plus or minus means plus 1 generally they will take. Positive value only possible Nn, negative is not possible. Nd plus under root of b square means Nd square minus 4ac. 4 into a is 1, c means minus plus Ni square is possible. 4ac, 4 Ni square by 2a. This is the formula is possible. By using this formula, you can determine concentration of electrons in an n-type extrinsic semiconductor. I hope you followed. By using this, you can determine, understand. But suppose you want to find out the conductivity, how we can find? The next one we can see. Conductivity in n-type extrinsic semiconductor. How to find n-type extrinsic semiconductor. But I want here conductivity. But the total conductivity in the n-type extrinsic semiconductor is calculated by conductivity due to electrons plus conductivity due to holes. Electrons concentration is more. Here now, majority carries electrons only. So sigma equal to, I can write sigma n is nothing but already we know. What is the formula given? Nn into Nn. Nn means electrons in the n-type extrinsic semiconductor. And Nn into Q into mu n, you know very well. Plus holes concentration means number of holes in the n-type extrinsic semiconductor into Q into mu n, you can apply. Mu n you can apply. But you can write one point here now. But if Nd equal to, if Nd is far more greater than Ni value, you think it's so. If Nd is far more greater than Ni, you please watch. If Nd is far more greater than the Ni value, this value will be negligible, 0 only possible. At the time, what is going to happen now? Root and square cancel, Nd plus Nd, 2Nd. 2 cancel means Nn is approximately equal to Nd only we are getting now. When, if Nd is very large as compared to Ni, otherwise you can't use it now. I can say if Nd is far more greater than Ni, I can write Nn is approximately equal to Nd only possible. Nd only possible. At the time, what happens now? Nn is approximately equal to Nd only possible. But the holes are, the minority carriers are very less. Those charge carriers can be negligible also. This concentration is very less in n-type. You can neglect. Finally, sigma conductivity in n-type extrinsic semiconductor is approximately equal to what? Nd into Q into mu n only possible. concentration of electrons more, concentration of holes are very less. That value is a very small. Even you neglect it, it doesn't matter really now. Understand my point now? That is very important now. So anyhow, by using this formula, you can find. The next one, I want to give information regarding the p-type extrinsic semiconductor. P-type extrinsic semiconductor. I would like to explain p-type extrinsic semiconductor. But how the p-type extrinsic semiconductor is formed, how the energy band diagram is to be plotted, that are all I want to explain here now. Understand my point now? That I want to give the now some information I will just wait, I will give now. Just a minute. Yes, but how the p-type extrinsic semiconductor is formed? Click. Thank you, sir. Click. Thank you. Okay, what we want to discuss in p-type extrinsic semiconductor. Whenever intrinsic semiconductor is doped with trivalent atom, then it is formed p-type extrinsic semiconductor. Trivalent atom contains 3 valence electrons. Example, we can take it as a boron. I say if trivalent atom, pentavalence means n-type I said now. If trivalent atom is doped with intrinsic semiconductor. Intrinsic means I said pure type of semiconductor. Intrinsic semiconductor. Then p-type extrinsic semiconductor is formed. P-type extrinsic semiconductor is formed. Sir, but practically n-type and p-type extrinsic semiconductors role is very, very important now. If you want to form the p-n junction diode, it is a must, p-type and n-type materials. Even you want to form the transistor, it is required. What is required? P-type and n-type. Without p-type and n-type, we cannot find. So because of the advent of the extrinsic p-type and n-type extrinsic semiconductor, we are finding so many applications in the electronics field only, we can say now. But simply I can write here now, I have taken intrinsic semiconductor here now. Intrinsic semiconductor, it is doped with trivalent atom. Then only it is forming p-type extrinsic semiconductor. This is a p-type extrinsic semiconductor. The trivalent atom means I said it contains 3 valence electrons. It contains 3 valence electrons. 3 valence electrons, I can say. 3 valence electrons. So 3 valence electron means, as an example, I will take one example, boron. Boron, gallium, indium, all these will come under the trivalent atom. One example, boron is enough. How the bond structure, then after we can draw how the band structure will be possible now. If it is taken the bond structure, I can draw like this now. There is a boron. This is boron. But here it is trivalent atom is doped with germanium or silicon, your wish. Okay, we can put here now silicon or germanium. Doped with silicon or germanium. This is with silicon. It is also doped with, silicon. But you know very well, still structure goes this side. This structure goes this side, this structure this. It goes like this. But the addition of these impurities made very, very small, I said already. The last class only I explained. The addition of the impurity made with intrinsic semiconductor is very, very less. But the change of conductivity will be a lot only now. That's a very, very lot. So because of the addition of, finally the point here you try to understand. Because of the addition of the impurity, conductivity increases or decreases, means anybody can say it increases only now. But one more point you need to catch. Very higher concentration of, more concentration of the boron is added. Impurity concentration more added. Can you find the conductivity of the more or conductivity of the less is possible here now? Anybody can explain? Anybody can say conductivity increases or decreases? I said less concentration of trivalent atom is made at the time the conductivity is going to increase. Impurity addition very less now. The impurity addition is made more. The conductivity increases or decreases. That's my question. 100% conductivity is going to be decreased only now. Why conductivity is decreasing? The addition of the impurity is made more. How it is possible? How it is decreasing? Anybody can say? How we can say? What is going to happen? At the time, what is going to happen now? The electrons are easily cannot move in the material now. That means electron is, the collisions of the atoms are easily possible in the material. Collision is possible very easily now. That means when the impurity atoms are added more, the free electrons are going to hit the what now? Other atoms very easily, because number of what now? Foreign atoms are existing more. When they are hitting the more easily, that what not, the transition period will be decreasing only here now. The transition period is decreases, and also what you can say, conductivity also decreases in the material. Understand now? That means the addition of the impurity made more at the time, recombination rate is going to be increased more and more in the material. At the time, conductivity is going to be decreased only, I can say that now. But anyhow, in the silicon contains how many number of valence electrons? Means 4 valence electrons only now. That's where we are adding less concentration of the impurity. Understand now? And how many boron atom, how many electrons, free electrons are possible for the boron? Means 3 valence electrons are possible. These the fourth one, these 2 electrons can form the bond, one bond. These 2 electrons sharing can form one more bond. And also, yes, Arvind Kumar Singh, thank you, sir. Okay, thank you. Why thank you? I don't understand. Arvind Kumar Singh said, thank you, sir. But because of the sharing of electrons, 3 covalent bonds are formed. Here it doesn't form any bond because their creation of the whole is formed. But it doesn't have one more electrons to create the bond here now. At the time, thereby creating a whole creation is possible here now. Now the point what I wish to say here is, in the bond structure of the p-type extrinsic semiconductor, p-type extrinsic semiconductor, the 3 covalent bonds are formed and one creation of the whole also possible here now. What are the majority carriers existing in the p-type extrinsic semiconductor? Means holes are the majority carriers. What are the minority carriers in the p-type extrinsic semiconductor? Means the electrons are the minority carriers in the p-type extrinsic semiconductor. How the energy band diagram will be plotted for the p-type extrinsic? This is the bond theory. But what about the band theory? How we can draw the energy band diagram for this? The energy band diagram for this, I can draw like this. I can draw like this now. This can be plotted in this way. Just I will draw the now. This is the conduction band, you know very well. That is the conduction band. And valence band is going to exist here, here. There is a valence band. And one more energy band, discrete energy band is going to form very close to the conduction band, very close to the valence band in p-type extrinsic semiconductor. In the n-type extrinsic semiconductor, I explained one more small energy band creating below the conduction band, I said. But here the above the valence band, here you can find the creation of new energy level. Creation of the new energy level here. Okay, just wait. Like that it is creating exactly. The creation of the new energy level is possible like this. Like that it is creating here now. Like that it is creating. But majority carriers are holes, those holes are going to occupy here. In this new energy level, holes will occupy because of the addition of this impurity. Now you try to catch, but this valence band contains number of electrons. They are within the bond. To move the electrons from here to what now? Here. To occupy this hole, electron is going to move from here at low energy level, or at low temperature. Electron will try to move and occupy this hole. When the electron is occupying the hole, thereby creating the hole only now. The one more electron is going to move from here to here and occupying this hole, thereby creating one more hole. Like that, certain number of holes are occupied by the electron, only now. When the temperature you are increasing more and more, you think it's so. The few number of electrons may go from here to here. Suppose 4 electrons are moved, we can assume 4 holes are going to create. But certain excess holes it is existing due to movement of the electrons from here to occupy the holes only now. Finally, we are finding the concentration of the holes are more and concentration of electrons are more in the p-type extrinsic semiconductors. Holes are more, electrons are less only possible. That's why we can write majority carriers in p-type extrinsic semiconductor. Are holes. And what about the electrons? They become seminority carriers only. But how we can find the concentration of the holes in the p-type extrinsic semiconductor? That I will discuss. Now. But from the electrically neutral condition, I can say P suffix P. Here I can write to find concentration of the holes. How to find the concentration of the holes at first. Then after I can go for the conductivity also. But in the p-type extrinsic semiconductor, p suffix p equal to, I can write n suffix p plus n means minority carriers of electrons in the p-type extrinsic semiconductor. P suffix p means the holes in the p-type extrinsic semiconductor plus Na. Na is nothing but the acceptors concentration only now. Acceptors concentration. But because of the impurity, we are getting this acceptors concentration. But to find the p suffix p, n suffix p is to be converted in terms of the p suffix p only now. How we can convert? From mass action law, I can write from mass action law. From mass action law, concentration of holes, minority carriers, what now? Concentration of the electrons, minority carriers are nothing but the concentration of electrons only. Minority carriers, concentration, minority carriers are nothing but the concentration of electrons in the p-type semiconductor. That I can determine Np equal to Ni square by what? N p suffix p only now. Ni square by pp. This we got from the what now? Mass action law. Suppose I am substituting here now. P suffix p equal to, I can write n suffix p means Ni square by p suffix p plus Na. Then I want to cross multiply here now. After LCM, I can write p suffix p into p suffix p whole square equal to p suffix p equal to, we can write Ni square plus Na into what? P suffix p I can write here now. P suffix p I can write. Then I can form one quadratic equation here now. P suffix p whole square minus Na into p suffix p minus Ni squared I got, minus Ni squared, that equal to 0. From this equation we can determine concentration of holes. P suffix p equal to minus b minus plus Na minus plus or minus, plus is enough, don't take minus now, holes must be positive, under root of b square Na square minus 4ac minus plus Ni squared by 2a is possible, 2 only possible. So finally the formula which is required to find out the concentration of the holes is Na plus under root of Na square plus 4Ni squared by 2. By using this formula, you need to find out concentration of the holes in p-type extrinsic semiconductor. That means the majority carriers in p-type extrinsic semiconductor you can calculate by using this formula. Once you are finding the majority carriers, minority carriers you can get. Minority carriers you can get from the what now? Mass action law only, by using the mass action law. So electrons and holes concentration you can find this way. What about the conductivity? I want to find conductivity. Conductivity in p-type extrinsic semiconductor. P-type extrinsic semiconductor. The total conductivity, just like a n-type, total conductivity equal to conductivity due to electrons, conductivity due to holes only. We know conductivity due to electrons. Electrons means we know that now. N into already given. Conductivity is nothing but, what is the formula given already? For concentration of electrons in p-type extrinsic semiconductor into Q into mu n. Sigma p means what I can write now? The concentration of the holes we can find by using the formula concentration of the holes, we can find P suffix P into Q into mu P, we can write here now. Mu P is possible. But the PP concentration of the holes is approximately equal to Na only possible. This is a very large, Na is very low. But I say here, you please watch here given, the P suffix P equal to Np plus Na is given. Np is nothing but the minority carriers of electrons only now. Na is nothing but acceptors concentration. This acceptors concentration is always very large as compared to the what now, these minority carriers. At the time, P suffix P is approximately equal to Na only. Directly you can write, no problem. Directly you can write, is approximately equal to Na. And also, electrons concentration is very less. We can neglect this part also. In P-type extrinsic semiconductor, this concentration very less. This portion we can remove directly. Finally, sigma equal to what? Na into Q into mu P is applicable. So by using this formula, you can determine conductivity. This is approximate value only. But I want to get exact value, means Np plus Np into Q into mu N plus Na into Q into mu P will now. Understand? This slight variation only will come now. Like that, the determination of sigma is made. Understand now? So far you followed, I hope. Understand now? Now, just I want to give before completing this session, just I want to give some information regarding the IMS Gate Academy. The students who wants to take the admission in IMS Gate Academy can contact with these numbers. They can contact with these numbers. If you are having the if you are calling to this number, you will get the clear information regarding the gates. If you joined in IMS Gate Academy, what are the advantages are possible? If you know very well about the program futures, you can understand what advantages you will get it now. But more than 800 hours of the live classes with live interactions possible, theory book and exercise books. The exercise book contains more than 4,000 questions. The more than 34 years gate questions banks with video solutions done here now. And also in this gate questions bank, every problem is done and alternative solutions for certain questions given, and also key points also given, and also for certain questions video solutions also given here now. The 12 personalized one-to-one mentorship session also possible. More than 130 online tests with video solutions, the mock tests and many more. So don't delay. If you want to get admission, you call to this number. Understand my point now. But the good experienced faculties are in IMS Gate Academy. If the students are willing to take the admissions, you will get benefited because every faculty is ready to explain the full subject in the classroom there. Understand now? Even in the online also. Understand now? Anyhow, don't delay and have the what now? If you want to discuss with our pupils, you call to this number now. But I hope so far you followed this subject. Thank you all. In the next class, you will see the problems based upon the certain problems, certain questions also. Thank you.